Yeah, my name is Sophia Shoemaker. You can find me at Wise Cobbler at all the places. I work as a freelancer, and one of the companies I work for is Full Stack IO. We write lots of tech books. Two of the tech books we've written are Full Stack React and Full Stack React Native. They're super awesome. You should totally buy them. And you can find both of those books at fullstackreact.com. Okay, so before I get into the technical aspect of my talk, I want to give a little bit of background. So for various political, social, economic reasons, there are large numbers of orphanages in many regions in Africa. For example, in Uganda in 1992, there were 2,900 orphanages, and in 2013, there were 50,000. So governments in these various regions in Africa have begun to crack down on some of these orphanages because they're not all that great. In some cases, there's abuse happening. It's just not a great situation. And the governments have also shut down or suspended or banned international adoptions. So this last year, I've been rebuilding an application for a nonprofit organization called Kaimei, and they are working with orphanages and the government in Ghana. They want to get these children out of the orphanages and back with their families. Oftentimes these children have parents or other extended family members still alive, and Kaimei works to reunite these children with their relatives. So the application that I built for them allows them to collect all that data and generate reports based on that data. Hopefully, sorry my talk is not as fun as a party boat like Jared, but it's good. It's good stuff. So the first iteration of this project, I built using PHP and Laravel. Any PHP people out there? And this worked fine for the most part, but as the team started to use it, it was getting increasingly frustrating for them because their internet connection is limited. The internet infrastructure in Ghana is not like it is in America, and even in some places in America, it's not that great. So every page load was requiring a round trip to the server, which when your internet is slow is not a great experience. And they also wanted the ability to use the application out in these orphanages where there is no internet at all, and they wanted to be able to collect the data and input it directly into the computer rather than taking a paper form out to these orphanages and then taking it back to the office and entering the data in at their office. So with all of these constraints in mind, I set out to rebuild the application using AWS Lambda and React. The database structure was fine. So in rebuilding the application, I kept the same database and focused on the server-side code and the client-side code, the changes that needed to happen there. So I used AWS Lambda with a Python backend. I won't go into any details about AWS Lambda, but I will say that switching from an EC2 instance to using AWS Lambda, oh, sorry, hold on just a sec. Just gotta get my, so switching to an EC2 instance, from an EC2 instance to Lambda significantly reduced the costs on AWS. So right now, basically, Kaimei is paying for the database and nothing else because Lambda is super cheap. The other aspect about Lambda that I really find appealing is that I don't have to worry about maintaining a server. And since I'm the sole developer on this project, I don't really want to worry about that. So AWS Lambda is a really, really good option for that. And then obviously on the front end, I use React. Okay, so going offline with React, how does this work? Adi Osmani has written a really great 6-part tutorial on creating progressive web apps with React, which I really highly recommend. And I use this tutorial as like the jumping off point for my journey of creating this offline application. And so some of my slides have a lot of content from his tutorial, but I would highly recommend going to that URL right there and reading his tutorial because it's really great. So what is a progressive web app? I'm sure some of you are familiar with the term, but I just want to make sure we're all on the same page as I use the term throughout this talk so that everybody understands. So there's a couple of attributes of a progressive web app. One, it's progressive. It works for every user regardless of the browser choice. It's responsive, which means it works on desktop, mobile, tablet. It's connectivity independent, so it's enhanced with servers workers, which I'm going to talk about in a minute, to work offline or on low-quality networks. It's also safe. It's served via HTTPS to prevent snooping and ensure content hasn't been tampered with. There's a few other attributes about progressive web apps, but these are the ones that I picked out that I thought were relevant to the talk and probably the most important. So one of the first things you can do to improve your web application is use a tool called Lighthouse. If you're not familiar with Lighthouse, it allows you to audit your web application to see where you can improve in performance, accessibility, and other progressive web application stuff. I actually tried running running Lighthouse on the previous version of my application I built with PHP, and Lighthouse just stalled. It hung forever, so I'm not sure if there's like a bug with Lighthouse or if my application was really that unprogressive. I don't know. But it's a really great tool. Okay, service workers. So in order to make any web application accessible offline, you have to use service workers. Service workers are just JavaScript files that allow you to cache resources such as other JavaScript files, CSS, HTML, that can then be available offline. Service workers only run over HTTPS, and they make use of promises. So let's take a look at how a service worker works. There are 3 stages in the lifecycle of a service worker: the registration phase, the installation phase, and the activation phase. So to register a service worker, we have to add some code that looks like this. The outer block, the if service worker in Navigator, it just detects whether or not service workers are supported, and then before trying to register it. Then the register function registers the service worker, which is just a JavaScript file in our application. The scope parameter is optional and can be used to specify a subset of your application if you don't want to use the service worker in your entire domain. And then there's a then and a catch changed to the handle to handle what happens when the promise is resolved or rejected. So in the installation phase, that's when all the files actually get downloaded to the machine. The assets are actually cached. So in this case, in this instance, we're calling our cache v1. That's that cache.open section called cache v. We're calling the cache v1, and it will be the version 1 of our site's resources. And then the final phase is activate. So if your service worker has previously been installed, like we have our version 1 installed here, and then there's a new version of the service worker available. For example, you've updated your application and you have new assets that need to be cached. The new version is installed, but it's not activated yet. It's only activated when there are no other pages loaded that are still using the old service worker. So as soon as there's no other pages using the old service worker, the new service worker is activated, and these new files are available. Okay, so that was a lot. That's a lot of code, right? The awesome thing is that Create React App does this all for free, so you don't have to worry about it if you end up using Create React App, which is awesome, because there's lots of smart people working on that stuff, and you don't have to worry about it so much. Okay, one other aspect of this project that was pretty critical was actually determining when the user was online or offline. So there's a Navigator.online property that returns the online status of the browser with true, meaning the user's online, and false, meaning offline. There are some gotchas with using it, but in general, it's a pretty reliable way to detect whether the user is online or offline. So in the application, as I started detecting whether or not the user was online, I started writing a bunch of code that looked like this, which is great, but it was getting a little messy. And so to dry up my code a bit, I created a function that took 2 callbacks as parameters, an online callback and an offline callback. So this is what my code looked like. So if the user was online, it ran a function that handled online stuff. And then if the user was offline, it called a function that was for stuff that happened offline. This way, I could customize what happens when a user's offline versus online. So I combined this function out. I use this function with another functionality called local storage to determine how and when to store data. So local storage. Local storage is a property on the window object, and the stored data is saved across browser sessions. It's a simple key value store that has a set item function, a get item function, method, set item method, get item method, and remove item method. Only strings can be stored in local storage. So if you want to store anything other than a string, like an object, I had a lot of JSON objects that I was getting from the server, you have to turn your data into a string. So another caveat about this is that while storage limits for local storage are larger than something like using cookies, you can't store gigabytes of data unless the user specifically allows for it for a domain. Typically, the local storage limit is like around 5 to 10 megabytes. That's just one caveat to be aware of when using local storage. So here's an example of how I use local storage in the Kaimei application. Since I was getting a lot of data back from the server in the JSON format, I use this JSON.stringify method to turn the JSON objects into strings. And then when I would get the data from local storage, use the JSON parse function to get the data back into a JSON format. Okay, so this is what the Kaimei application actually looks like. Hopefully you can see it. It's a little small. So there's a couple things going on here. This is just a list of everybody named Sophia. So this button right here, I don't know if you can see this black button right here. When the user is online, if they click that button, that will store that particular record in local storage. And the key for that local storage item is the child's UUID, and the value is the entire child's record. So this whole process right here, when they click on that button, they have to do that online, obviously, because they have to grab the most recent data for that record. But once they are offline, the capabilities of the application are the same. So one other aspect of this is, you see that first table row there, it's highlighted red. That means, and if you can see here, that button right there is not black. That means it's been downloaded and stored in local storage. That red highlighted table row means that there has been data that's been updated offline that needs to get uploaded to the server. It was just a more visual way to show the user that, hey, there's some data here that hasn't been uploaded to the server. So this is how I actually grab the data from the server and load it. So if you see here, I have my online/offline function, and I check. And sorry, the first line there is to check and see if there's actually a child's record stored in local storage. So if there is, then I have a few checks to see how that data should be displayed. And if there is no child record stored in local storage, then I just grab the data from the server. That's for when the user's online. So as I showed you earlier here, anytime the user saves anything offline for a child record, I set a flag in local storage and the child's record in local storage, indicating the record has an optimistic update. So you can see here, this put orphan data, that's saving the data. If the second function here, data.update equals optimistic, that means the user's offline and this data has been saved offline. So then when the user's back online, they're shown this screen for any child's record that has been updated while they're offline. So they have the ability to manually upload that data back up to the server once they've gotten back with internet connection. So this is a team in Ghana that does all this awesome work. And in thinking about how to build this application, I knew I could impose a few constraints on how the offline interactions would work. The team in Ghana is very small. There's just four people who are working to gather all this information about the children. So it was easier to manage how the users would be allowed to use the application. I knew that there would not be a risk of a user potentially editing a child's record online and someone else editing that same record offline because the whole team works together. So obviously, if the team scaled up and there was more people working on this application, I'd have to rethink my approach, and there would be different constraints, right? Possibly I'd have to, if a user downloaded a record, I'd flag that as being saved for that particular user. Or I'd have to rethink how this offline application would work. So in this process, there were a lot of challenges and frustrations that came with this project. Dealing with offline applications is, as I learned, not an easy task at all. So at one point, the team in Ghana was having some issues using the application, and I couldn't reproduce the issue on my end. We had a Skype call. We're video conferencing, and they were literally holding a laptop up with the laptop offline and showing me via the video conference what was going on, and I had them opening Chrome DevTools and inspecting elements because you can't do a screen share with a computer that's offline. So it was the time difference. There's a language barrier. They speak English in Ghana, but it's not the same as the way we speak in America. And the technical capabilities of the team in Ghana, it required a lot of patience on both ends, right? Sometimes things would not work for them and they'd be really frustrated because they would want to enter in data and it just was buggy. So it was a good learning experience. We've got most of the bugs worked out, and it's in general a much better user experience. It's definitely faster. They don't have to make as many round trips to the server, which is just a lot better for them. And finally, the last thing I wanted to share is this concept that I've seen kind of floating around the internet in a few places. I've heard it from or seen it in several places, so I can't remember exactly where I've seen it. It's the Japanese concept of Iike Guy. I hope I said that right. So everyone, according to Japanese culture, has an Iike Guy, which is this purpose in your life. So finding it requires a deep and often lengthy search of self. It's really important. It's an important cultural belief that discovering one's purpose in life brings satisfaction and meaning. So there's these four circles. I guess I don't know if you can see it way in the back there, but the yellow circle is what you love to do, and the green circle is what the world needs, and the blue circle is what you can be paid for, and the pink circle is what you're good at. So when you combine all four of these circles, that's like, Iike Guy, like this, purpose in your life. And so for me, this project has been an Iike Guy experience. I got paid for it. I got to write React code, and I'm pretty good at it. and I love it. And it's something that these children in Ghana need. They need to be with their families. And so I loved being able to stretch my React skills and feeling like this, and I just felt like this project was like a really good conglomeration of all of these things. So I hope you can find your Iike Guy experience in using React, because we all love using it, and finding some higher purpose for using it. So that's it.